Let's take a look at a current mirror for constant current, okay? If you have two identical transistors with the same base to emitter voltage and the same temperature, they'll have the same collector current, okay? So we have two transistors here. If we're putting a current through this one, it's going to be mirrored over here through the load on this one. So, and this one's going to be constant here because we have a fixed value here. So the current on this load is going to stay constant, okay? So now this transistor here, it's a diode connected transistor. We're taking the collector to the base here. And if we have to figure the current through here. So we're going to use 12 volts, and we're just going to try for 20 milliamps here. So we take our VCC minus the base emitter voltage, which is 0.7 volts. So that comes out to 11.3 volts, and we divide that by our 20 milliamps. So this resistor should be 565 ohms if we're going to get 20 milliamps through here. Okay, so we're getting 20 milliamps through this side here. Now we come down to our base here. The two bases are tied together, and the current through the base is equal to the emitter current divided by beta plus 1. And on this one's the same thing. It's going to be equal to the emitter current, emitter current divided by beta plus 1 over here. Now this beta plus 1, you'll see that all the time. The emitter current is equal to the base current plus the collector current, and the base current plus the beta times the base current, which is your collector current, is equal to B plus 1 times your base current here. So it's just another way to write it. Instead of writing it this way, we just say beta plus 1 times your base current here. That's all that beta plus 1 means. Now, if you got 100 or 200 beta, that doesn't even matter. So, but you'll see it written like that. So now we've got our 20 milliamps coming through this one, and we're going to have the same current through both of these bases. So hopefully this one and this one, the collector current on these are going to be the same, no matter what load we put on there. Now these two resistors, these are degeneration resistors, emitter degeneration resistors, and they're used to guard against beta unbalance, okay? So if your collector current increases, the current down here will increase, causing the voltage across RE here to increase, and then that'll cause the base voltage to increase, and the base current to decrease, and it keeps your collector current from increasing. That keeps your collector current from increasing. So you just get a little bit of feedback, so negative feedback here, and that keeps your collector current more stable. If the beta is off here. Now, if they match, you don't need that. Those are optional, but they help out there. Okay. So we've got our 20 milliamps coming through here. We should have 20 milliamps coming through through this side here too. So we're going to take a look and see if it actually works. There we go. Can we see that? Does that fit in there? Okay, I'm going to turn that one on. Turn that one on. This is put them down here. This are milliamps. I got 19.7, 19.6. Pretty good. And this is our voltage here. Okay. This is the voltage on the load over here. Okay. Now, you notice we have 20 milliamps here and 20 milliamps on this one here, and the total milliamps coming into the circuit is 40 milliamps. 39.5 here. So we're only using 20 milliamps to light these LEDs here. You see them there? Put it up a little higher. So we're kind of wasting 20 milliamps, but so we got 40, 20, and 20, and then we have our voltage over here. And I've got all these LEDs in there now. If I start taking the LEDs out of here, the current should stay the same. Okay. Yeah, so the current's staying the same, but the voltage is changing, okay? And I take another one out. There we go. So we're sacrificing the voltage to keep the current the same, okay? So I could actually add a few more LEDs in there, but we're maintaining our 20 milliamps here. Of course, we got our 40 milliamps coming in over here. So it's working good, and that's a current mirror. So yeah, you can put a bunch of diodes or LEDs in the circuit, and they'll all light up with the same brightness, all with the 20 milliamps going through them. So you wouldn't be able to do that with just a resistor. So there we go, stays the same, and the voltage will drop off a little bit to compensate for the current there. You don't have much load on these, but there we go. So that's our current mirror. But you got to realize that you're using 40 milliamps here to control 20 milliamps on your LEDs. So that's it. Thank you.